It just does the split point to the right side, +1, right. And that's how the quicksort function works. And let's see it in action. Quicksort. I have to print it out this time. And I have an error for some reason. Of course, because I've forgotten to write down the leftmost element. It starts from 0 and goes to 10. So, yeah, wrong one. Starts from 0 and goes to 10. And there you go, it's been sorted. And now the last sorting function is the binary tree sort, and it's a bit long. I've made a structure called the tree node because I'm using list nodes and linked lists to make this binary tree sort, creating data and then two nodes, one to the left and one to the right. And then I put the build tree function, where I build the whole tree, inside a structure called tree sort. And the build tree function asks for a node, name of the node, a node declared by the struct tree node, and a value, that is the value from the array. So if the any value of a value of the array, the chosen value of the array, is smaller than the data inside the node called whatever you call it here, position this time, pos. If that is happening, then, and if the position to the left is equal, so the node inside the position, the node left inside the position is equal to null, then it will create a node. It will create a new tree node. It will give the value, this value, to the data inside the left node, and it will create its own nodes to left and right, to null. Else, if the value is bigger, then it will put the value, it will call the function again. So it checks again the left node of the pos and the value, and it will do this thing again. Okay, so if the value is then bigger than data inside the pos node, then it will do this. So if the pos node and its right element is equal to null, then the node pos, then it will create a new node again, and its own linked pointers will be set to null. Else, if this is not null, then it will do this function all over again. There, that was difficult. So that's how it builds the tree. It's inside the tree sort structure. This is how it builds the tree. So mainly it checks if the value is smaller than the data inside this node, and if it's smaller, then it will go to the left, and it will check if there's a free space. If not, it will create one. Else, if it's bigger, then we go to the right. There, that's basically how it works. And this is the print tree function. I'm not using the print map function because I cannot print out the same way that I'm printing an array. So I have to print the tree, to use the print tree function. It just checks if the position, if the node pos and its left pointer is not null, then it will print the tree. Else it will see out. It will redo this function. Else it will see out. If the position to the right is not null, it will do the same thing again. So then Now we get to the actual sorting function where we use all that information that I just explained above. I create a pointer node and a root node, and I allocate some space for it and write the name of the array. I give my data link an array, and I call here the tree sort structure. Where's my tree sort structure? This tree sort, and I make an element of that tree sort, which is the build tree function. So it uses the build tree function, and I called it binary sort. And this for loop goes through the whole array, all the elements of the tree. So if for I is 1, starts out from 1, we do the binary sort. That is, we call the build tree function for the root node and the array called R and I there. And then we print out the tree. That's how it works. So we already have to print the tree, so I don't need it. Then I'm just gonna use the binary tree sort function there. And of course I forgot to change these. And there. And that's how it's sorted. So basically that's how it works. And this is just again the print map function where it just prints out the array. These are all the functions that I'm using. There. Then